Hello, I'm Antoine Soulé, a postdoc at McGill University in Professor Aminiman's lab, and I'm going to present to you a work we've done with William Ma and Professor Simon Rousseau on COVID-19. So it all started with a very interesting dataset published by the Biobanque québécoise de la COVID-19 that included measurement of the circulating proteome of hundreds of patients of the pandemic. And we thought that this dataset was a great opportunity to build a classification of patients complex enough to capture the heterogeneity of response to COVID-19. So we picked all patients that were positive for COVID and hospitalized and add those circulating proteome data that consist in the measurement of the relative expression of nearly 5,000 protein in blood sample. So we normalized the measurement of those 731 patients and used it to cluster them. Our clustering method was unsupervised, hierarchical, with the twist of having two levels to make it very resilient to few percent leaving or joining the dataset, because those are real data, patient may retract their consent, etc. The number of clusters were also determined in an unsupervised manner, and we ended up with 6 clusters, 6 endophenotypes, EPs in short. And when we look at those EPs, we see that we got a nice gradation of the response captured, with EP1 on the right side with best prognostic, and EP6 on the opposite side with by far the poorest prognostic and outcome, and the other EP adding nuances to the picture. This difference also shows in cares with a very significant difference. We got p-values at in enrichment and depletion that goes down very low. Also in severity, with EPs with mostly moderate and mild patient, OSP with severe, no mild, most deaths, etc. So captures a response. And when we look at risk factor, it's also interesting because, well, we see part of what we expect. EP6 worst outcome enriched in male, EP1 best outcome enriched in female, but at the same time, we get EP2 and 4 that are also relatively enriched in female, but without the same great outcome. EP3 enriched in male, but not nearly as bad as EP6. Same thing with age and BMI. Oldest EP by far is EP5, that's the worst outcome. Best BMI are EP2 and 5, not best outcome. So captures the response without falling into any binary division. This is also complemented by many complementary analysis amongst all the additional data BQ19 provided. Here you got a few examples with enrichment in different blood test variable, enrichment in metabolic pathway, we also did metabolites, enrichment in symptoms, and we also did comorbidities, prior, etc. So in all cases, EP1 and EP5 stands at opposite, and the other EP helps comparing, helps interpreting the results. And all those results complement each other. Way more in the paper, of course. A quick word about our predictive model. We wanted to see if we could say anything about patients without circulating proteome data. So we try to attribute an EP to those patients based on their blood test result. All right, so we made another cohort to set a test set, main cohort, train set, simple model, predictive model, and see what the prediction look like. Turns out they look like the EP, and that led us to think that we can say something about those patients, something relevant. In the room left, you got bypass summary, or preprint, or meta-archive, and main reference of the paper. Thank you for your attention. Thank you for listening. I wish you a nice day and a nice conference.